Next we have Bianca Possamai, I tried, or Lakemounts, Hotspots of Productivity and Biodiversity. Thank you.
Right, good afternoon. So I'm Bianca Possamai, I'm a postdoc at the University of Vermont. I work with Professor Jesse Stockwell and Professor Adam Marsden, and I talk a little bit about my research. Yes, okay. If I... Other one? Yeah, that's fine. So first, just introducing the idea of seamounts. Probably all of you heard about that, but seamounts are these mountains in the open ocean. They rise more than 1,000 meters to almost to the fault zone, never breaks the surface, but in a very abrupt way. And then these changes circulate, the water circulation, causing a welling of nutrient-rich water to this fault zone in the open ocean, so boosting fertilizing these waters. And also provides a substrate for a lot of benthic organisms, creating a different ecosystem in these areas. And these areas are related to an increase in chlorophyll productivity, creating like an oasis in the open ocean, and also areas with high fisheries catch. And we thought maybe we have similar ecosystems in lakes. So what about the Lakemounts? So this is just some examples of some offshore reefs that in some of the large lakes we have here in North America, like Lake Huron, Lake Champlain, and Lake Superior. And these are examples of offshore reefs that have this abrupt topography. Just to show in Lake Champlain, one of our sites, this is a Skyler Reef. It's an offshore reef, and you can see in the figure in your right.
There's a pointer on there.
I shake too much for this. So you can see that it's a very abrupt topography. So we thought maybe this is also changing circulation around these areas, and similar process may occur. So just to look at the background, what the research we have about these areas. So in 2010, we had this was the first one that we know that was publishing this idea of lakemounts and seamounts being related, and this paper showing that these abrupt topographies can restrain the migration of mycetes, so they come up during the night and they get, because of the topography, they get trapped in these upper layers, and then providing food for a lot of fish. And then last year was the second time we saw the seamount word in a paper talking about lakes. So where these authors saw genetic diversity of lake trout in this very offshore lake mount. So then we use all this knowledge and all these concepts, and then we are proposing this idea that we need to study these lake mounts in these lakes, these systems in lakes, and see if we can relate this process with the ocean in the smaller scale in lakes. So the idea is that we have an offshore area in lakes, so we have all the productivity occurring in the photic zone, and everything that is not eating, that's not used in this photic zone is going to the deeper waters, and not used, it is just sinking. And then if we have a lake mount in this open area, it will create a barrier for the circulation, and then will cause this upwelling, bring all these things that were not used to this photic zone, and then boosting primary productivity, and then we'll create an opportunity for a lot of also benthic producers to grow in these open areas, so microhabitats for a lot of crustaceans, and then attracting fish and creating an oasis and open areas of lakes. And another thing that we know that large in deep lakes things that occur is the internal stations, that also, because of the thermal stratification during summer, we have these internal waves, and the idea is within the lake mounts we already have this upwelling occurring, and when this sums with the sage, it can upwell even more. This cold water bring all these nutrients to the photic zone, boosting productivity in So our question is just to investigate if these lakemounts are biodiversity hotspots. And our objectives with this study was identify upwelling as a possible mechanism in these areas, if we can relate to sage events as well, this upwelling occurrence, and if the biodiversity in these lakemounts are higher than offshore areas without lakemounts and nearshore areas that we know that are more biodiverse than open water. So our study site was Lake Champlain, the main lake. And then we collected samples in 2 nearshore areas in the New York side of Lake Champlain, 2 Lakemounts, so this open water steep reefs. One called Fisheries Rock and the other one Skyler Reef, and 2 open water areas without the Lakemounts influence. In these areas, we collected samples in the equilibrium, methylinium, and hypolinium, following the contour of the reef, and same thing with the other sites. So what we collected, to detect upwelling, we deployed temperature sensors through the water column in different depths for almost 3 months. And then biodiversity assessments at least 2 times in each site during the summer of 2023. So for zooplankton, we did vertical tours for large zooplankton. For benthic invertebrates, we collected with ponderographs in these 3 different stratus as well. And then for fish, we collected using gill nets, bottom set in the contour of the reef and also the other areas, and also three different meshes, and 3 different meshes, similar meshes, with floating gill nets. So to the results. So here is at temperature. So these 2. Okay, I'm gonna try. So these and these are 2 different lakemounts, and this one is the offshore graph. So in the y-axis depth, and then time in the axis, and the colors. So cold colors cold temperature, warm colors warmer temperature. And then we can see that there's different things going on. So in the first Lakemount here, Skyler Reef, I'm tracing a line in 15 meters because the thermocline is usually about this depth. And then we can see at the first Skyler Reef, there's a lot of upwelling going on because the temperature is pretty cold. It's around 10 degrees Celsius in the summer. While the other reef in the offshore area, we can see there's much higher temperature. So that means in this Lakemount is a constant upwelling occurring, so changing a lot the circulation. In the second one, we have occasional ones, same thing with offshore. Then I ran a model just to try to see if sage has something to do with that, if the wind, if there's something to do with that. And then we see a relationship, lower temperatures are related to south-southwest and north-northwest winds, which if you look into the configuration of the lake, which is north-south, is the preferential wind direction for sage occurrence. So we could relate that the sage events in the other area, this upwelling events in the other areas are really related with the sage events. So likely boosting also the Lakemount upwelling. So about the richness and diversity, so for the overall benthic invertebrates, zooplankton, and fish, we collected 89 taxa in the nearshore, 82 in the Lakemount, so pretty much comparable. Remembering that this is in the open lake area. And then 30 taxa in the open area with no Lakemount, and then diversity indexes as the channel is very similar nearshore with the Lakemount. And then when we do a plot, we did not detect any difference in composition and abundance for these 3 sites, but we did see differences in the hypolimineal is less diverse and lower abundance compared with equilibrium and methylinium. But then when we take it off the zooplankton community, because water flows, then it's pretty much similar species in all the sites, when we remove zooplankton and just work with fish and benthic invertebrates, we can see that there's a separation. And then this is the offshore community, and then nearshore and Lakemounts are pretty much very similar communities, very comparable. So meaning that these Lakemounts are really very different, like very good and different habitats in the open lake. So just to show the diversity in the three different sites. So nearshore, Lakemount in the middle, and offshore. So for zooplankton, we have similar communities, so 16 species, 20 species in the Lakemount, and 15 in, offshore without Lakemount. But as you can see, we have almost 2 times more abundance, nor density of zooplankton in the epimelion of Lakemount zones. So this may be an evidence of this high primary productivity attracting zooplankton. And same thing with the epimelion, it still has we have a little bit more density compared to the other areas. For benthic invertebrates, just to show, we have a lot of taxa identified, and as you can see, so near shore 55, which is a lot of insects that we don't find in the open areas of the lake, but comparing the Lakemount with the offshore areas is just like very different abundance of taxa, but just breaking into groups, to be easier. We can see that the epimelion of Lakemount, there's a lot of abundance. Density of benthic invertebrates, very comparable to near shore, but most of this is the zebra mussel, which is an invasive species that basically takes over the reef. But still we have a high abundance of benthic invertebrates in these areas. And then talking about fish, for the near shore and Lakemount, we have also comparable number of species, 18 and 16, and offshore much lower number of species. And the CPUE in grams, we can see that near shore we have a higher number of catch, but the species that are using, we also have a high catch in the Lakemounts, but the species are a little bit different. We can see that these red colors are more related to salmonids, walleyes, so these predators that everybody here has a lot. So yeah, this is the difference between this near shore and Lakemount. Lakemount is providing this habitat for these big predators. And also we had one detection of sturgeon, so a species of concern, so that showing that maybe this habitat is very good for this species. Summarizing, so we could detect upwelling occurrences in these Lakemounts, and we also could relate this to sediments. And zooplankton maybe show us a little bit of evidence that some higher productivity is going on around this area. We see that there's a lot of substrate for vegetation, which is providing habitat for lots of invertebrates. There are prey for fish, and also endangered species using this area. So looks like it is a good habitat for fish, and maybe must be considered for conservation purposes. Next steps in this research, we are now going deeper on this analysis of primary productivity. So we are collecting water for nutrients and also analyzing the phytoplankton community, and also water circulation with lots of fancy equipment to see if we can detect these vertical flows and corroborate this upwelling occurrence. And also there's work about cryptobenthic fish that we didn't assess in the other in this first event, and we can detect if there's the cryptobenthic assemblage using these reefs as well. And I have a bunch of people to thank you because it's a lot of field work and lab work, and my fund from Red Lake Fisheries Mission, and thank you all for watching.